Welcome to The Explainer, where we break down the big stories. Today, we're digging into a major showdown that's brewing in the world of AI.
Okay, so what if I told you that you could make an AI chip that's 73 times faster than Nvidia's best? But, and it's a big but, there's a catch. That's what we're diving into today, a real David versus Goliath story happening right now in AI hardware. We've got a wild new idea going up against the undisputed champion.
But before we get to the challenger, you gotta understand the king of the ring. So let's talk about Nvidia.
And when I say king, I am not kidding. Nvidia isn't just a leader. They're basically the whole market. We're talking up to 90% control of the high-end AI chip space. It's their world, and everyone else is just living in it.
So what's their secret sauce?
Well, it's all about versatility. Their GPUs, combined with this massive software ecosystem called CUDA, are the gold standard. They can do pretty much anything you throw at them. But that incredible power has a downside. These things are absolute beasts when it comes to power consumption, and they are not cheap, especially if you only need them for one specific job.
All right, so now let's meet the challenger. It's a small startup from Toronto called Taalas, and they are taking a completely, and I mean completely different approach to this whole problem.
See, instead of building another one of those do-everything general-purpose chips, Taalas is building something called an ASIC. The easiest way to think about it is like this. An ASIC is a specialist. It's designed to do one single thing, but it does that one thing better and faster than anything else.
And their process for this, which they call hardcore, really takes this idea to the absolute extreme. What they do is they literally hardwire one specific AI model, say Llama 3.1, right into the silicon itself. It's permanently etched on there. And because they only have to customize two little layers of the chip, their whole fabrication process is unbelievably fast. We're talking a brand new chip in just 2 months. That's insane.
So what do you get for all that specialization? Well, this is David's slingshot right here. Their first chip can generate an absolutely mind-boggling 17,000 tokens per second per user. Just to put that in perspective, that is blazing fast.
Okay, so this is where it gets really interesting. Speed versus flexibility. Let's put these two totally different philosophies head-to-head and see how they actually stack up.
So check out this performance gap. When it's doing its one specific job, the Taalas chip is up to 73 times faster than Nvidia's top-of-the-line H200. I mean, that's not just a little better, that is a completely different league. It's a genuine quantum leap.
And if you think that's impressive, it gets even crazier. Taalas hits that speed while using up to 10 times less power. Think about what that means for a data center. You've got a Taalas rack humming along at maybe 15 kilowatts, cool enough to be air-cooled. Compare that to an Nvidia rack that can pull up to 600 kilowatts and needs its own complicated liquid cooling system. The implications for cost and energy, they're just massive.
And of course, all that power efficiency translates directly to your wallet. I mean, look at the total cost of ownership here. Running a model on Taalas can cost less than a single cent per million tokens. That is a jaw-dropping reduction compared to running on a GPU. This could totally change the economics of AI and make all those apps you use every day way, way cheaper to operate.
Okay, but here's the catch we talked about at the beginning. This is the big one. To get all that speed and efficiency, Taalas has to give up, well, pretty much all flexibility. Each chip can only run one model, period. So if a new, better version of that model comes out, you can't just download an update. Nope. You have to make a whole new chip from scratch.
So this all sounds pretty incredible, right? But the question is, how does this actually work in the real world? This is the reality check. Can David's slingshot actually hit the mark?
Right, so you might be thinking, can a company just, unplug their Nvidia setup and slot in some Taalas chips? And the short answer to that is absolutely not. It's nowhere near that simple.
This is not a plug-and-play situation. You need a serious amount of engineering work to get Taalas up and running. You have to compile the code, you have to integrate the hardware, and then you have to literally manage a physical inventory of different chips for different models. And on top of that, sometimes their super aggressive optimizations can cause the AI to make mistakes or even hallucinate, so you've got to be really careful with quality control.
And then there's the manufacturing gauntlet. Just getting these things built is a huge challenge. Now, Taalas uses an older 6-nanometer process, which helps, but they're still fighting for space at TSMC, the factory that makes pretty much all the advanced chips in the world. And guess who TSMC's #1 customer is, booking up their capacity years out? Yep, it's Nvidia. So they're literally competing for factory time with the giant they're trying to challenge.
So where does that leave us? What's the final verdict here? Is Taalas a real threat, a true giant killer, or is it just a super clever but ultimately niche idea? While the most likely future isn't one or the other, it's probably both, working together. Think about it. It's a hybrid approach. You'd use Nvidia's super flexible GPUs for all the hard stuff, training, research, experimenting with new ideas. But then, once you have a final, stable model that you know you're going to use a ton, you deploy it on hyper-efficient Taalas chips to save a boatload of money.
And really, this whole story points to a much bigger picture. As the AI industry grows up, we're seeing this huge shift away from one-size-fits-all thinking. The market is specializing. It's all about finding the right tool for the right job. And that's creating space for all sorts of new, specialized hardware.
So that leaves us with one last big question to chew on. Is the future of AI going to run on these flexible giants or on these hyper-focused specialists? You know, the more you look at it, the answer is pretty clear. It's going to run on both. The real story here isn't about who wins or who loses. It's about how these two completely different ways of thinking are going to come together to build whatever comes next.